The topic to discuss in this article is the redesign of aerospace courses focused on industry innovation. This investigation is performed by Yacid Farah and Alba Romo, both students of aerospace engineering and the Autonomous University of Chihuahua. The main thing we want to focus on is the development of aerospace engineering education, going from pedagogy, where we can observe the teaching methods and the main problems that exist for the students when they are trying to learn. We want to improve the quality of learning to generate better professionals who are more committed to the aerospace industry, and in turn, sharpen the skills of each of the students to develop individually at their own pace and interest. Another very important point to address is the need to update the curriculum. Aerospace engineering is a technology that is advancing rapidly, getting a vital role in our society. Ranging from manned lunar excursions, solar system exploration, and satellites from ecological Earth study, and improving this can benefit commercialization on space stations and products of high quality for humans and military concerns. This is why education must evolve hand in hand with the industry, even faster, in order to generate better quality engineers who can develop an industry and innovate intelligent and in an effective way. So we are going to explain some of the changes that after an investigation we consider the most optimal way to improve the education of aerospace engineering. With this article, our main objective is to present in the undergraduate curriculum the foundations required for modern aerospace engineering, where the student is prepared to continue learning even after finishing school. The students are expected to begin their studies of mathematics and physics, but at the same time, they must start to learn from the beginning relevant information for their studies in the aerospace field. In the following semesters, the engineers should learn sciences applied such as materials, thermodynamics, and mechanics to continue learning about aerospace engineering. It is in the last years of the career that the students must focus on the specific subjects in the aerospace field, learning processes, methodologies, and problems presented in the industry. It is important to highlight the necessity of laboratories and all kinds of practical experience that they can obtain from the school. The purpose here is to be able to offer all this experience to the students in order to generate better professionals for the future. To begin, we must emphasize the importance of an optimal doctrine. Based on the power ranking score of educational systems around the world, we will find the information that the best educational system right now in the world is Finland, with 114 points. The following are Japan and South Korea. These are the first places that exceed 100 points. Now, if we go to the 20th place, we will find the United States with a rating of 47. The question that arises is, where is Mexico? The level of education is so low that it is not present in the list comparing it to the first places in the United States. It gives us a difference of more than 50 points. Looking at it in broad strokes, it shows us that Mexico is in a very poor level of education, and just that is what we want to change. We want to position Mexico amongst the best. So, why does Finland come in the first place? The reason is that they are constantly evolving with their teaching methods and focus on multidisciplinary projects, and also integrates new technologies to teach. The great development of their education is due to the great time they spend studying, and this does not refer to spending hours in a classroom. It includes practices, activities, projects, experiments, visits to specialized companies, and this helps to keep the students motivated to learn in different ways, and so they will grow potentially to become better students and engineers. To achieve an analysis of how the development of a student is affected, we must rely on teaching errors in order to propose a better method. One of the main problems in the classroom is the large number of students, each of whom has a different way of learning. In order to control this, we propose to separate the students by their learning method and their abilities, thus creating a more pleasant environment for learning and make it easier for each student to learn in their own way. In addition to promoting teamwork, it is necessary to increase the individuality of the student, which provides another type of experience. It is important to solve projects individually to better understand the problems that may arise. A very big problem is that there is only one teaching theory in class. Activities related to work in real life must be implemented so the student can understand in a more specific way and a practical way how the things work outside of the school. Self-learning should be encouraged without falling into leaving all the work to the student, making students want to learn more because they like it and not because of an obligation that the school made them to. Each student is different and each must be taught differently. Although there is a common curriculum for all, one should not expect everyone to learn exactly the same way. They must develop the knowledge and interest for each one, thus creating a variety of professionals with different ideas and thoughts. And the educational objectives we seek are, first of all, academic fundamentals. It is expected that graduates can integrate their knowledge of the fundamentals principles and apply it to their professional life. Engineering practice. Graduates use their engineering skills to plan, develop, and complete engineering projects. Teamwork and communication. Graduates must demonstrate the ability to communicate their technical ideas and results verbally, as well as being active and effective participants in a team. And professional development. Graduates develop their knowledge by actively contributing to society through their profession and professional activities, giving us a chance to innovate and have a better future. As we can see, we develop a study plan that we consider optimal for the correct performance of the students. For the first semester, we have speech and communication skills. This is a really important subject because one of the problems that many engineers face in the early stages of their career is learning to communicate in a public manner. So in this sense, speech and communication skills should be a main factor that students should focus on. Then we have calculus, physics that includes theory and laboratory practices, introduction to aerospace engineering, which must be here because the study plan in the university does not focus on the main aspects of aerospace until the students have reached the sixth semester. That is why the implementation of introduction to aerospace engineering is a fundamental aspect to add on. Now we have English 4 and environmental science and engineering for the first semester. For the second semester, we have applied calculus, linear algebra, advanced English 1, digital computation and programming, basic of electrical and electronics engineering, aircraft systems and instrumentation. And this is very important because learning the basic systems and measurements in the aircraft industry is an essential knowledge that the students should know to be efficient on the work field. Then there is chemistry, which includes theory and laboratory practices for better understanding of this subject. In the third semester, we have statics and thermodynamics. Both include theory and laboratory practices. Structures lab, communication in the engineering profession, and this is a key component in the students' learning basis. for them to give a better impression in the industry being as formal as one can be. The next subject is professional ethics and life skills. This one must be considered essential also because the aspect of ethics in the engineering profession is vital, because the students as future engineers should have the consciousness of knowing that they will be future designers of technology and will have an impact on society. Students with good ethics tend to look for a better future, improving the quality of life as a consequence, therefore having a better future for our society. Then there is Advanced English 2 and numerical methods. For the fourth semester we have dynamics, mechanics, and circuit analysis, all of these which include theory and laboratory practices. There is also vector calculus, TOEFL 1 exam preparation, and probability and statistics 1. The load on this semester makes it a filter in the career for the students that really want to be engineers, because the subjects of the semester tend to be very heavy in the material aspect as well as the logical aspect, so overcoming this semester can be a bit difficult. In the fifth semester, the subject of metallurgy is taken considering theory and laboratory practices. Advanced Drawing 1 will be using NX software, Technical English, which is an optional subject, but it is recommended to take it this semester. Principles of management is added, which creates advantage having the knowledge and ability to manage certain areas in the industry before graduating, and if the student does not become a manager, it can help the student in a personal manner to be more efficient and organized in his daily life. And the last subject of this semester is probability and statistics 2. In the sixth semester, we have the subjects of aerospace structures and aerodynamics that include theory and laboratory practices. We have also business economics and quality systems. Aerospace structures is added to the career to give us an example of how the spaceships and aircrafts can be modeled. And the business economics is added because it can give us an insight of how the money management works in the industry, and it could help us out in the long run. The design aspect in the career is not fully boarded as it can be, so implementing more subjects in this matter could be useful for the students that have in mind being designers in the future, making this an opportunity to begin the development of this knowledge and increase the potential of future designers. As it can be seen for the semester, the learning is already focusing mainly on the specific knowledge of aerospace engineering. So for this level, students already have a broader knowledge and focus on the aerospace industry, which allows them to start with volunteering and internships that make them learn professional practice and give them experience. In the seventh semester, the subjects are mechanics and environmental space, writing and comprehension program 1, analysis and evaluation of projects, and this subject is an essential part of the managing aspect for the students to learn, so that when they work in the industry, they will have the tools to begin the projects and finish them with efficiency, making them excel against their peers and thus outstanding more for the company you are working or the industry or enterprise. Then there's aircraft structures 2 and orbital mechanics for 7th semester. In the 8th semester, we have the subjects of propulsion, aerodynamics 2, which includes laboratory theory and practices, satellite engineering, and design on aerospace covers. And as you can see, this semester is mainly focused on the design of the aircraft, which may be a difficult semester, but it will provide the knowledge necessary for a competent student when they graduate. In the 9th semester, we contain heat transfer, application of safety management capstone, and philosophy. This last one is an overlooked subject and more in the engineering field, but using it wisely can make you open the perspective, giving you an advantage point from other peers for having this habit of analyzing and evaluating before acting on anything. Uh, as you can see, in the last 3 semesters, the load of the subjects is much less than at the beginning. This is so that the students have more time to dedicate to volunteer on internships and that they can add the optional subjects that are offered without saturating their agenda. Even though the last semesters are the most heavy based on the material scene, we can arrange and manage our curriculum as we desire. Finally, the optional or extra subjects that we consider important will be discussed. We have the principles of engineering economics, robotic automation, aerospace engineering thesis, spaceflight mechanics, rockets and mission analysis, aircraft navigation systems, mechanical vibrations, thesis seminar, human factors in aviation safety, and design of engineering hazard controls. Each of the optional subjects are created so that each student chooses which path to follow, depending on their abilities and enjoyment. This encourages the creation of professionals with different knowledge and methods, opening a variety of fields to work on. The development of optional subjects helps students feel comfortable and have several options for their development, taking into account their personal interests, making it more pleasant for the student to go to the college. In conclusion, we believe that making these small changes can optimally change the development of education in aerospace engineering in Mexico, which will help both improve their educational level and have a better level of professional in the aerospace field. This will help develop the industry and position Mexico as a constant contributor to technology and aerospace advancements, helping the country by bringing more inversions to our field. And this is all we have to share. Below are all the reference and information consulted. Thanks for your attention.